You ever notice how two apps that do the exact same thing, like, say, book a hotel room, can feel so different under the hood? One might be simple, another a total beast of complexity. Well, the answer to that is buried in their blueprints, and that's exactly what we're going to dig into. It all boils down to one key question.
And this is the heart of it, right? It seems like it should be easy, just add more servers or something. But as we're about to see, the gap between serving one small country and serving the entire planet forces engineers to play a completely different game. The rules just totally change.
So, to really get our heads around this, we're going to check out two different hotel booking systems. They're like two case studies, each with its own set of problems to solve, and you guessed it, its own unique architectural solution. On the surface, their mission is identical. You pop open the app, you find a hotel, pick your dates, and boom, you book a room. Easy. But it's everything happening around that simple goal that flips the script. Okay, so let's meet our two players. On one side, we have the OHBS, built just for hotels inside Jordan. Think of it as a local boutique shop. And on the other side, we have the GOHBS, a massive global platform that has to work for anyone, anywhere. Same basic function, but you can already see the scopes are just worlds apart. Let's start with the smaller one, the OHBS. To really get why it's built the way it is, you have to look at what it was asked to do, its requirements. This is like looking at the blueprint for a single, well-built house. You know, what's really telling here is how focused these needs are. It's for one country, Jordan, it only has to deal with one currency, and this is a big one. It doesn't need to be ready for some massive viral explosion in users. The system knows its boundaries, and that's actually a feature, not a flaw.
This line right here from the actual design document is the key that unlocks everything. A single server. That one little constraint tells an engineer pretty much all they need to know. It means the entire operation can live inside one box, which makes things so much simpler. And that leads you to the perfect tool for the job. A classic, centralized, three-tier architecture. You've got your user interface, the application logic doing all the booking work, and the database holding the information, all neatly packaged together. For a system this size, it's efficient, it's easy to work on, and it doesn't break the bank. It just makes sense. Okay, now let's completely switch gears. We're not building a house anymore. Now we're designing a sprawling, interconnected global city. This is the GOHBS, the Global Online Hotel Booking System. I mean, just look at the difference. We're talking millions of users now. Crazy amounts of traffic coming in from all over the world all at the same time. The system literally has to be everywhere at once, and the pressure for it to never go down is just on a whole other level. Let's just sit with this number for a second. 99.99% uptime. It sounds high, but what does it really mean? It means the entire global platform can only be offline for about 52 minutes in an entire year. That's less than an hour. That level of always-on reliability is a non-negotiable demand, and it completely changes how you build things. And that demand for uptime leads directly to this blunt little statement from the Global Systems Design Doc. That simple single-server model we just talked about, yeah, it's a complete non-starter here. It would just crumble under the pressure and could never, ever hit that uptime goal. It is fundamentally the wrong blueprint for this job. So, what's the answer? You go with a distributed architecture, usually built with something called microservices. Instead of one giant monolithic application, you break the whole thing down into dozens, maybe hundreds, of tiny independent services. You have one service that just handles payments, another for search, another for user profiles. If search is getting hammered in Europe, you can give it more power without touching anything else. If one little service fails, it doesn't take the whole ship down with it. This is how you get to 99.99% uptime. So let's bring this all home. We've seen the two systems, we've seen their very different blueprints. Now we can connect the dots and see exactly why they had to be so different. This slide just lays it all out perfectly. Just look down the columns. The local system has a limited scope, a moderate number of users, and standard needs for availability, which leads it straight to a centralized architecture. The global system, massive scope, millions of users, and insane availability demands, which absolutely requires a distributed architecture. The final design is a direct reaction to the initial requirement. And that's the big takeaway here, isn't it? You don't pick an architecture because it's new and cool or because everyone's talking about it. You choose it because it is the only design that can actually handle the job you need it to do. In software, just like building a skyscraper, form has to follow function. Which brings us to the final, really practical piece of this.
How in the world do engineers make these huge decisions out in the wild? Well, it's definitely not guesswork, and it's not magic. It is a methodical, very deliberate process of digging in, analyzing, and then making a choice based on the evidence, based on those requirements we keep talking about. It pretty much boils down to these 3 steps. First, you have to truly understand the scope and the scale you're playing with. Then, you nail down the absolute must-haves, the non-negotiables, like that 99.99% uptime. And only then, once you know all that, do you pick the blueprint that's tailor-made to get the job done. And that really is the most important lesson of all. A super complex microservices setup would be a wasteful, complicated mess for that local Georginian booking site. And a simple, centralized system would be an absolute catastrophe for the global platform. There is no single best way to build software. There is only the way that is right for the job at hand. So the next time you're using an app, any app, just think about this for a second. Was it built for lightning speed? Was it built for millions of people? Was it built to never, ever fail? Because hiding just under the surface are these invisible requirements that dictated every single design choice, shaping your experience in ways you probably never even noticed before.